hopefully what I do when I have a look at these type of questions, okay, I look at the equation, okay, so we've got the 0.5, 100 lies on the line of this graph as shown below. The value of K is what? So when I've got to find the value of K, one thing I'm always doing is I'm actually having a look at the values of the axis too. So I'm actually looking at X, and I also see that this is Y. Now, because this is X, I just substitute it in as X, this X value, and that as Y, and it will tell me what K is. So all I need to do here is I'm just going to do my working out here, is I've got the equation, Y equals kx squared. Now this isn't x squared, this is x, so I'm going to substitute it in. So the value of y is 100 and the value of x is 5. So I'm going to do 100 equals k bracket 5 bracket squared. Now I can do this on my CAS and I could do solve. And I mean, you could use x for k, but I like to do z just to distinguish it for you guys. So all I can do here is literally bring up your keyboard, do a solve, and I'm just going to type in, 100 equals z bracket 5 close bracket to the power of 2, or I don't need the bracket necessarily there. And then comma, I want to solve for z, and then hit execute, and it will tell me it's 4. Alternatively, you could actually solve this as 100 equals k times 25, and then divide by 25 on both sides. 100 divided by 25 will mean that k equals 4. So either way, we get to B, and that is it. That's 1 mark from the exam. That was 2017. Again, you don't really get many of these questions. Sometimes you don't get them at all, but usually you'll get 1. Any questions? Let's see if you guys can do this one then. This one's from 2014. So there you go. I just want to get that right. And I'll just do this. I'll give you a minute 30, I reckon, on this one. Okay, and just working through some of these exam style questions today. So you can work through this with me, or you can find this on our class resources under linear. It's called 10F2I examples PDF. We're just sort of going to go question through question period 1. Next period, you guys can just finish off their tasks on Edrollo. At the moment, we're just trying to find the value of K. If you've got answers, feel free to put it into the chat. I'd love to see your answers in the chat line. Thanks, Athena. Do you guys need a bit more time? I don't see too many answers popped in. I'm hoping, normally you got 2 minutes to do a question like this, but I hope that this would be one of the questions you can get through a bit quicker. Any more answers? Excellent, they're starting to come in now. It's obviously a little bit more time, that's okay. You're probably not up to exam speed yet, considering this is the second example, so it's perfectly fine. I'll give you guys just another 20 seconds or so. Thank you for your answers. Great, that's really good to see. You guys are kind of getting this. Another 10 seconds. Okay, let's look at this question. So the point 220 lies on the graph of y equals k on x as shown below. Okay, so we want to find the value of k. Again, the things I look at here is I'm looking at my axes, intercepts. It is x and it is just y. So this is the value of x and this is the value of y. All I need to do is substitute it into the equation that's given to me and I'll find and solve for the k. So 20 is y equals k on 2. Now you could use algebra times 2 across. 40 equals k. Alternatively, if you're not comfortable with algebra, which is perfectly fine, you guys have a CAS in here and I really don't care. I prefer to use this. You go 20. Whoops. Actually, let's do solve. You can do it a couple ways. Solve 20 equals, I'm going to use z divided by 2. And I'm going to solve that, comma, for z, hit execute. Alternatively, if you don't like to do that, you can just literally put in the equation 20 equals, and you could do a fraction if you want, z on 2, and then you can actually highlight that as well. Interactivity, advanced, solve, and solve for z here, and then hit OK, and it'll get 40. It does exactly the same thing for you. So good to see you guys. Pretty much all got D, which is 40. Well done. 1 mark. That was 2014. Let's move on to the next one. I'll give you 2 minutes to have a read through this one and have a go. For those people who joined us a little bit late, you can download this yourself if you can't quite see. On school resources or our class resources, just go to the linear folder in our school resources, linear recursions, and it's called 10F to 10I examples.pdf. First period, we're just going to go through this just to get you guys. This is pretty much the 4 sub-chapters all together. And if you have finished, put your answer in on the chat line. You guys are getting the hang of it now. I see a few already coming through, which is good to see. The speed is kind of speeding up. These are the questions hopefully you find a bit quicker. B seems like the answer. We'll see how you guys go. Okay, I'm going to stop there and go through it. So guys, on the lesson plan, you'll see that my notes for this are, if you have to find the value of k from a graph that has x axis y and x, note this has axis y and x, substitute x and y values into the formula and solve for k. That's my summary notes for you. They're compressed, they're short, but hey, I think to me that makes sense. And that's pretty much what we've been doing, okay? If you have to find the value of k from a graph and has axis x and y, substitute x and y values into the form of k. Now, some things to note, in the exam's separated into modules, all right? So when you go into the module of linear recursion, this is what's going to happen, you know what I mean? That's different to data and statistics. So these are the things where you're going to have k, okay? So you'll be looking at that. So let's have a look at this one. So the graph below shows the braking distance in meters of a car at different speeds in kilometers per hour. The coordinates on a point of the graph are also shown. Okay, so that's the coordinates. It hasn't given us the values, but it shows it. The relationship between braking distance and speed can be modeled by this equation. Okay, use this model Using this model, the braking distance in meters when the speed is 60 kilometers is what? Well, straight away, when I'm looking at 60, I can kind of read off here, right? And I'm expecting my answer to be around, oh yeah, maybe around here-ish, you know what I mean? 30-ish. So around here looks pretty good. I can pretty much say it's not going to be E straight away. And really 24 looks a bit low, so I'm kind of question marking that. So already I can read off it, but I've got to actually get an accurate calculation. So I need to figure out what K is. This is sort of like a two-step process, which you guys might have realized. So we've got X and we've got Y, where X represents the speed and this represents the distance, okay? Because distance is my Y in this case and speed is my X. So I'm going to literally just substitute these in and solve for it. So my distance is 45. Again, this is not speed squared. Like you don't see this as squared, it's just speed. So I'm just going to substitute it in for X equals K times 45, and that needs to be squared. Okay, and then, oops, that should be 75. Nearly made a mistake there. So I'm just double checking my figures. 75 equals 45 squared, and I'm just going to solve that for X. I'm going to do this one on my, I don't know what 45 squared is quickly, so I'm just going to do this on my class pad, which I closed for some reason. So again, I mean, you could just go back and type it into the equation, but I like to use the keyboard solve today. I don't know why, but it just helps me. And I'm going to just do Z. I mean, you could do this as X if you wanted to. The reason why I don't use this is because you might get confused with this, but I'm just going to show a quick way to do it. I typically do it as X because I find it a lot faster to solve for X, because as soon as you execute, it just, you know, well, you can do it as Z, but whatever. So I've got that there. Okay, now that's told me what the X value is. I would use this as a whole decimal now, put that into the equation. So the equation actually, now I want to find out, so my equation is basically braking distance equals 0.037 ... times by speed squared. Now the question is, using this model, the braking distance in meters when the speed is 60 kilometers per hour. The speed is here, so I want to know what the braking distance is. So I'm going to go 0.037 times by 60 ... squared. Now we don't round off in this answer, so I'm literally going to take this answer here, and which I'm just going to hit times because it's taken my answer, times by 60 squared, and hit execute. And no, because it's done solve, I can't do that. So I'm going to just delete that. I should have done that. Just click and drag that. Beautiful of this thing. What have I done wrong there? I've got 133.
75 and 45 the wrong way round.
Did I? I did at the start, did I? Oh, X and Y. Sorry, thank you. Speed and distance. Oh, I stuffed that up completely. I did do it wrong way. Thank you. 45 equals K. I was just completely checking you guys. I never make mistakes. See, I would probably put that in as a possible answer in here, but realistically, I knew that was wrong because I already knew that my answer should be somewhere in here. So I'm like, hang on a moment, that's not right. That's not what I'm expecting. So that's how you can sort of check off these if you're getting it right or wrong or not. And thanks for helping me out with that one. So I can go back up here. That's going to be, let me just go through this. Braking distance is Y. So that should be 45 equals, yep. So it should be 45 here. Times X equals 75. That'll be it, which is 8 to the power 0.0. Oh, that's a lot better number. Now, oh, by the way, guys, this number, what this number actually means is it's 0 point, because you've got to move the decimal point 3 points. It's going to be negative. So I need to move my decimal place 1, 2, 3. So it's going to be 0.008. Look at that. 8, 1, 2, 3 places. So that's actually what the number is. Hit execute to that. I'm not hitting execute to that. I'm hitting execute to something else, which is 28.8, which clearly you guys had and I didn't, which is really good that you had that. So yeah, thank you. I did have that around the wrong way. Yeah, you get what I mean, times 60. This should be, yeah, that's it, 0.008 times 60 squared, which equals, my braking distance is going to be 28.8, which is B, which a lot of you guys have. If you want me to go through that again, I'm more than happy. I might, but I think you guys have got the hang of it, because a lot of you guys had B and I didn't. 28.8. Stylus didn't work there, which is B, which is great. Excellent. Let's move on to the next one. Nothing like a shonky bit of explanation there. So really, we're just going to substitute in X and Y into this equation. Speed, just check that is 75, 45 for here. That's going to be 75 squared. Solve for the value of K, which you found is 0.8. Put it back into the equation once you know what that is. Okay, we know what it is, 0.008. Then we want to use this when the speed is 60. So then you're going to say 0.008 times by 60 squared. What is my answer for that? And you find it's 28.8. Well done. I think I made that a lot harder than what it needed to be. We'll come back to question 4. No, we won't. No, we won't. We'll do question 4. Have a go at question 4. I'll give you maybe a minute and a half on that one. Do you guys need a bit more time on this one? This one's a tricky one, but it is a bit of revision. So I've just put this one in here. It was from stuff that we've done a little bit earlier. I'm going to show you guys a couple of ways to do this. So I'll show you, I suppose, the mathematical way that I'd like you to do it, but also a way, if you're struggling and it's a multiple choice question, how you could answer it pretty easily. All right, I'm going to go through this one. So a shop sells compact discs to CDs, and we've also got DVDs. CDs are sold for $7 each. Okay, so I know that CDs and DVDs are sold for $13 each. Bonnie bought a total of 16 discs for $178. So that's compiled of DVDs and CDs, or just DVDs or CDs, we don't know. How many DVDs should we buy? Well, she spent $178. And that came from, she purchased, a certain amount of CDs. And the CDs are $7 each. So it came from, 7 like $7 per CD. So let's C be the number of CDs that she bought. And we can say 13 would be for the number of DVDs that she bought, right? So we're trying to find out, you know, this multiple of it. How many DVDs did Bonnie buy? It is a tricky one because we don't really, it's quite hard to figure out, well, how do we know the quantity that she bought for it to get there and be right? So one way you could do is you could actually just go through these and go, well, she bought 3 DVDs and DVDs are 13, and you know she bought a total of 16 discs. You could literally just go 13 times, 13, she bought 6 times 7, plus you're going to then have 3 DVDs, 3 times 13. And you say it's 130. And you could just go through the process like this. Okay, so then that would be 5 DVDs, and that would leave her then, because she had a total of 16, of 11. 98. Did I do that right way? Sorry, I think I've done that wrong way. DVDs are the first one. Sorry. She bought 5 DVDs. DVDs are 13. Yep. And she bought, then she would have, stuff that up. Sorry. My purchase price each. I'll do my DVDs first. So I've got this right. So what I'm going to say, the first one, she had 3 DVDs. Let's do DVDs first. And the DVDs are $13 plus. I'll do this again. If she bought 3 DVDs, that means she would have 13 CDs, and the CDs are $7 each. So I know I've got DVDs and CDs, and that needs to add 16. Then she bought 5 DVDs and 11 CDs would be the other option. That's 142. You can see C would be 7, and that would have to be 9. That's 154. And then you could go to 9. And then you could go to, it has to be 16, 9 plus what would be 16 would be 7, 166. And then, okay, obviously it has to be the last one. You can go 11. And if you bought 11, that would be 5 here. And you can see that's 178. So you can use the answers sometimes to help you get there. And you got to E. Did anyone go about it that way? Yay, no? So you can do that and literally just go through that, and then you can go, oh, well, 11 makes sense. So you can do that, and there's nothing wrong with that, which is fine to do that. The other way to do it is that, she bought 16 discs. So there is another way you can go about that, which you could create the equations. So you actually create an equation where, well, I know she spent $178, and that was from compiled of these discs, and try and solve those. I'll probably go about it like this. Just trying to see the other way you can go about it. How many DVDs should you buy? It's finally, so I would go about it like that way personally, just to see how many she bought, and do that. Does anyone have any other strategies how they tackled this one? Curious to know. Feel free to put on your mic if you did. Yay? No? Problem here is you've got 2 variables. You've got the number of DVDs, the number of CDs, where you're trying to solve for how many of those equals 178 with integers. Which makes it, a bit tricky. I'm sure there's another way you can solve it, but I'll have a look. Maybe we'll have a look at the answers. What did they say? Let A be the number of CDs sold, let B be the number of DVDs sold. No, that was the other equation I was trying to see. Of course. Thanks. I knew there was a simultaneous equation there. I just couldn't see it. That's the cost, right? That's the number of CDs. So that's the cost. And the other one, which is where I always stuff up because it's written in the one sentence. I always struggle with this one. That's why I always put examples down. This is a good example. There's 2 bits of information, 16 discs and that. The cost most people can get. But also she bought 16 discs, and 16 discs would be, well, the number of CDs and the number of DVDs. So this is my cost, and this is the, I suppose, formula, like how much it cost me in total. I don't want to call it cost, but sales, let's call it. where $7 number of CDs plus $13 number of CDs. And this is, I suppose, the number I bought. I bought 16 CDs, which is 16 discs, which is comprised of CDs and DVDs. And I always struggle with these ones because I can only see one equation. Maybe you guys are like me. I do find a lot of people struggle with that to find two equations, especially when these aren't multiple choices. It gets a bit harder. You just got to use guess and check. So what we can do is we can do simultaneous equations there. And we can say 178 equals, let's go with 7. We'll just do x because it's quick to get to, plus 13y. And then we're going to go down and we've got 16 DVDs equals x plus y. Whoops, I put that in the wrong place. Back on here, 16 equals x plus y. So remember, these are the number of DVDs that I've bought and CDs, which I'm going to have 16 of them in total, and that's how much it cost with me. And that's where two equations come from. I always struggle to see the second equation. So there you can see that I bought 5x, and in this case, we're saying x is the DVD, the CD, and y was the DVD. So I bought 11 of those DVDs, and that's the other way you can do it. Yeah, annoying. So that one's a really good example for you guys with simultaneous equations. These are the really tricky ones, I find. Some are pretty easy, but it's sort of like where you've got this, you know, you bought this for this much and you've got that for that much, and then you buy a total of these, like that's how many you have for that. And a lot of people ignore this as a linear equation, and they can kind of just go, oh, well, 7, however many I bought, plus 13, however many I bought, equals 178. But they don't realize that it's such a simple equation. Oh, hang on, 16 is what I've got, and that has to be comprised of so many CDs plus so many DVDs. And that's where that equation comes from. So I put that one in there as a good stumper. You guys gave me nothing. Thanks for your feedback. Let's move on. That one's just a bit of a refresher, just to go over some of the stuff of a really difficult question. All right, here we go. I want you guys to have a go at this. The graph below shows the relationship between x and y. The rule that represents this relationship between x and y is what? Okay. Can't just quite get that in. There we go. Let's give you a minute and a half on this one. This is the, have a go. See if you can get this one. And then just try and do that. Okay, Lena, just doing, we're just working through some exam questions for the first period. So you can find this on school resources or under our class resources. It's called 10F2E examples. It's under the linear folder. Welcome. Don't worry. I dropped out of internet yesterday. I was like, what's happening? I'm going to teach my classes, but it just came back on. So, yeah. So this will pretty much cover all the next 4 sub-chapters, guys. So I'm really happy if we get through this. So you can download it or you can work through with me. Or Adrian's locked in something. We'll see where everyone else goes. And I think this will be a lot more fun than just having Ed Rollo time. I was going to do it as a Kahoot, and I started, but it just took so long to get the answers and that in there. I'm like, oh, it's just taking forever. Great answers. Oh, good answer, Ashley. I like it. Give you guys like an extra 30 seconds. See a few more answers coming in. And if you're not sure, imagine if you had 25 seconds left to go in the sack. Take a guess, put one in. All right, nearly there. Okay, everyone else, just take a guess, just randomly take a guess, whatever you sort of came up with, if you can for me. If you're not sure, just randomly put in a guess and see if you get it right. You've got a 1 out of 5 chance right. Clearly, I'm not only working with 2 people here. And this is a different type of question. So you haven't seen this before. So it's fine if you get it completely wrong. This is a different type of one to the other ones we've been doing. Thanks, Navneet. Everybody else would get a 0 then, I presume. Come on. We're still trying to work it out. Let's have a look. Okay. Well, I'll take your silence of you just going to leave it as blank. This one's a bit different. So again, the graph below shows a relationship. Find the rule that represents X and Y. Okay. This is a straight line, right? So if it's a straight line, all we need to do is you can use Y equals mx plus c. Well, this is the y-intercept. The y-intercept is 0. So I just know it's going to be y equals mx because it's plus 0. And now the gradient. So I'm just going to try and find a nice point it goes through. Here's a nice point it goes through. It goes through, that's what, 6, 4. So the rise over the run, so it goes across 6 and it goes up 4. So rise over run is m. So m equals 2 on 3. So therefore, y equals 2x on 3, which is pretty good. Fantastic. So a lot of people would go with A, which is a fantastic option, which would be typically right in going through your data and statistics and that. So Ashley, I really liked your answer. The question here is, though, we've got to look at our axes, and that's why I was pointing that out before. That's y, and that's x squared. Now, because that's x squared, this is a graph of y and x squared. Now, it's a straight line, and you do exactly the same thing. But because this is x squared, it's not x. We need to do x squared. Now, actually, if your x was just x, like if it was just x like that, then that would be the right answer. But because it says x squared there, the only step that you guys need to do is literally just put a squared on there. So treat it exactly as linear, but put it as x squared. So that one is actually not right in this case because it is x squared. So this would make it your right answer. And hopefully that helps. So similarly, just say if this was like, I don't know, y to the power of 4, and this was like x to the power of, I don't know, let's make it a smiley face because it's Friday. Then your equation would be y to the power of 4 equals 2 on 3 x to the power of a smiley face. So I'm just trying to show you, because it's a straight line, you treat it exactly the same way as linear, except you just change, like that will be what your y is, and your x will be whatever your x is. Okay, so hopefully that helps you guys a little bit to understand how that works. I'm going to show you another way you can do this on your CAS if you struggle with the y equals mx plus c thing. You can actually go into statistics, and we can just make a straight line from this. We're going to put in 2 points. So we're going to put in, you find a point, and obviously the other point it goes through is the origin. Now I already found 6, 4. So I'm going to put in, where'd it go? CAS, hello. I'm going to put in 0, 0 as 1 point, and I'm also going to then put in 6, 4. And I'm going to do a lin reg, because a lin reg just goes straight through. Regression, lin reg, x and y. And I can see here it tells me that the problem with this is it's as a decimal, so it's like 2/3, so it doesn't work quite as well with that, but you can get the idea there that it's 0.666 x plus 0, obviously. Again, it's going to be y and x squared, so it's actually going to be by x squared. So that's one way you can do it, and you can see that the graph is the same as well. So that's one way. Another way you can do that there. Alternatively, if you do put your 2 points in, yeah, that's one way I'd go about doing that there. That helps. Another way, going back to these other ones that I should have showed you guys, is I think if you put your 2 points in here, if it's 0, 0, oh no, that won't work. Don't worry. No, don't worry, don't worry. Maybe not worry. So yeah, that's the way you can go about finding it on your CAS. Does that help, Ashley? Does that kind of make sense, how we do that? So I really like the answer of A. I was hoping a few more people would have said that, but it is a very common misconception, that one. But does that, yep, awesome. So guys, what I'm going to refer you to is to my other notes. How do we turn non-linear graphs into linear graphs? If a line is linear, treat it the same way as y equals mx plus c. So we just treat it. This is linear, right? We treat it as y equals mx plus c. Always check the axes if they are not x and y. So if they are not x and y, check the axes. Change y or x in the y equals mx plus c equation to what it states on the axis. So in other words, what I just went through there. So treat it as y equals mx plus c, which is what we did here. Oh, but it's y and x squared, so it actually needs to be y and x squared. So that's how it is. Let's see how well I transferred that across. Have a go at this one. Hope to see a lot more answers here. Come on, Ashley. I reckon you can get this one. Come on. So once you got your answers, guys, feel free to put them on. I'm really keen to see what Ashley puts in. No pressure. But hopefully you can see how quick these can be in the end and the difference between the two of them. So this one's a bit different to finding the value of k. This one's literally just treat it as linear, find out your gradient. They typically go through the origin. They always will. And then you just change your axes, your equation, your x and y to what it says. Come on, Ashley, you got 20 seconds. Hopefully you're there. Don't worry, I got distracted too. I've seen my daughter like pushing the pram across and back and across and back. I'm like, what's she doing? All right. Okay, good. Excellent. You got C. That's great. So a lot of you guys got C. I hope you did. Just quickly, again, probably manually is the quickest way over this. So it's a straight line. So I'm just going to do my rise and my run. So it's 1 on 4. So M equals 1 on 4. It goes through the origin. So it's going to be Y equals 1 on 4x. Or I could say it's, x. But this is x squared, this is y, so therefore it's actually y equals 1 on 4 x squared, or I could write it as y equals x squared on 4. So it has to be C, and that's your answer there. Does anyone want me to go through the CAS use again to show them how I could do this? I might just do that again. So on the CAS, if you're struggling with this y equals mx plus c, but hopefully we're literally just trying to find out the gradient. If you are struggling with that, let me know. You can put through the coordinates here, so it's going to be 4 and 1, 0, 0, 4 and 1, calc, regression, lin reg, hit OK to that, and you can see it's y equals 0.25x plus 0, but it's going to be y equals, so really then you got, well, it's y equals 0.25x, but x is going to be the x squared, so that's there. So y equals 1/4 x squared, that's what it is. Hopefully that helps. Good job. And hopefully you can see how quickly we can get through that. All right. Let's have a go at this one. Question 7. Just need to zoom out a bit. So the graph of y equals 3x squared is shown below. Another graph that represents this relationship between x and y, so this relationship is which one? This one's a bit trickier. Similar. So we haven't done one like this before, so it'll be interesting to see how you guys go. So good on you guys. Please put in your answers, whatever you think it is, and we will go through it and we'll see. So you will typically get answers of either A, B, or C on this one, not D and E, which is good to see so far. Let's have a crack at this one. Okay, so we want to find one that says y equals 3x squared, right? Okay, so straight away, don't guess D and E is on the other page. We can eliminate E because you can see that this is actually x cubed. So it can't be that one, okay? Also, we can see that this is x cubed as well, so it can't be that one either. So you're left with either A, B, and C. Now, the trick here is there's a couple of ways you can go about doing this. This is going from here to here. So which one represents this? Now, this is where it gets a little bit tricky. But what we want to do is we really want to substitute in the value of x and y, and then see what occurs. Now, these x values, this is showing the x squared value and the y value for each of them because it's x squared axis. It's not x. So this is x squared, and that's y. This 2, let me just zoom in a bit, because then I can actually draw on here. So we're actually looking again for, this is x squared and this is y, and this is also x squared and that is y. That is x squared and y. So we're trying to find a graph that gives us y equals 3x squared. So we need a gradient of 3, but what we need is I need this equation to be true. So what I can do is I can actually go, well, 27 equals 3 times x squared. Now, x squared value, this isn't x, this is x squared, is 9 in this case. So I just actually substitute that in because that is x squared. And 3 times 29 is 27. So 27 equals 27. So this is the correct one. Let's look at it over here. Y equals 3x squared. Okay, y is 3. 3 equals 3 times x squared is 9. Well, 3 times 9 is 27. So that does not equal, so it can't be that one. Over here, we're looking for y equals 3x squared. This is y is 27 equals, if you substitute in the value here for x squared, it's 3 times 3 squared. Oh, I've stuffed up there. Whoops. Sorry, 3 squared. Whoops, I've got to substitute in 3. So it's 3 times 3, and that is actually 9. Okay, a lot of people will typically choose this because what they do is they go, oh, 27 needs to equal 3 times 3 squared, which is equals 3 times 9, which equals 27. And I think that's correct, but it's actually not, because what you've done here is you substitute an x. Now, if this was just a, because if it has a graph of x, it's like this up here. So it's actually not that. Now, another way you could go about doing this is we know that we're looking for an equation that has y equals 3x squared. So again, we're really looking for an equation that has a gradient of 3, if you think about it. So another way you could solve that is like before, you know, we know that this graph has a gradient of 1/4 and it's y equals x squared. So we're looking for a gradient of 3. Which one has a gradient of 3? So that's another way you could solve that. Well, my rise over my run on here is 27 on 9. That equals 3. Therefore, that is y equals 3x squared. The equation for this one, right, because this is x squared, the equation for this is rise on run, which is 3 on 9. This is y equals 1/3, because it's a straight line, x squared. This one over here, you could also do the equation. You could figure out the equation for this one. So we're looking at rise on run, so it's 27 on 3. This is y equals 27 on 3, and it's going to be x squared. 27 on 3 is y equals 9x squared. So we still could use the same prior knowledge that we used before and find out the equation for each of these graphs. Let's have a look at this graph over here. This graph over here has a rise value of 27 and a run of 3. So that's going to be y equals 27 on 3x cubed. That is y equals 9x cubed is that graph. Okay, so hopefully you can kind of see how we can get the graphs pretty easily from here. Here, this has a rise on 1 of 3 on 3, so that is y equals 3 on 3x cubed. So the equation of this is y equals x cubed, just 1, x cubed, so it's x cubed. So you can see how we could answer this graph was one of two ways. We can just calculate each of them because they're straight lines. So I know that that is rise on run is going to be 3. It's 3x squared. Okay, straight away I can see it's x, and you could have got to your answer there. The other way you could do it is actually by substituting the values into the equation, but you've got to recognize that this is x squared. So I'm actually substituting in 9 for x squared, not 9 for x. So therefore, x squared equals 9. This whole thing equals 9. So it's actually 3 times 9, which equals 27, which is correct. A couple of ways you could solve that. I'm trying to show you a couple of ways that you could do that. But really probably the easiest way maybe to do the equation off it. But substituting in as well helps too. Any questions on that before I move on? So yeah, I think, you know, if you looked at question C, if we do the rise on run, that's, you know, y equals 9, but again, it's x squared. Okay, that's the equation for that. If you do substitute in the values, you've got to substitute in x squared equals 3, not actually, you're not going to square that because that is actually a coordinate x squared and y. So when you're substituting into here, this whole thing becomes 3. And some people really struggle with that. And I'm really good to see that a few of you guys said C, because that's probably what you would have done, I would imagine. Is that kind of how you went about it, Adrian, with that one? Sebastian? It's hard for me. Yeah. So yeah, that's a very common misconception, those ones. And these are tough questions, guys. So I've chosen the ones that are a bit more challenging. But I think if you kind of do those challenging ones now, you'll be like, oh yeah, and it becomes a lot easier. And that's why I sort of thought we'd go through this lesson, because it is 4 sub-chapters. It's a lot of work, and it does do it. Let's have a quick go at this one. I'm going to speed it up now. We're only going to spend 30 seconds on these, and I want to start getting through them. So go. Okay, if you haven't got this one, I'm going to quickly go through it for you. Really quickly, you can see that this is a straight line. So we're going to do rise on run. So this goes 2 and then it rises 5. So it is y equals 5 rise on run, and it's times by 1 on x, okay? So that gives me y equals 5 on 2x. So hopefully it's as fast as that. So literally rise on run, 5 on 2 times by this. Oh, wait, that's not x because it's actually times by that. Because originally it would be y equals 5 on 2 multiplied by x, but it's not x. X is actually 1 on x. So that's why it's that. So it's not that one, and we change it to that. And y is still y, so that's fine. Moving on to the next question. I'll give you guys 30 seconds. I might give you another 30 seconds. We'll just give you a bit more. Any answers on this one? Do you guys want a bit more time on this one? Otherwise, I will just go through it. Again, this is a straight line. So if it's a straight line, I'm just going to treat it as y equals mx plus c and then just change it. So my rise is 25.7 and my run is 0.44. So it is y equals 25.7 on 0.44 times by this 1 on d squared. So my equation will be y equals 25.7 on 0.44 d squared. There is none there because you don't have a decimal. So all we need to do is go into our CAS and we just need to go pull up our keyboard and we just need to do 25.7 on 0.44, hit execute to that, and it's going to give you this number. But this is rounded, okay? It doesn't say, it says it's closest to, so you could say 25.8, but it's going to be on d squared. Alternatively, you can just hit this and then you could run that again, but put it into standard. And it says 1,285 on 22. Now, there is none of those. It's not like 1,285 on d squared. So as an exact answer, it would actually be y equals 1,285 on 22d squared, but we don't have that. So the closest thing would be 58.4 on d squared. So that would be this one, because that actually equals, this actually equals, if you look at it from this line, 25.7 divided by 0.44 equals, y equals 58.4 times 1 on d squared. That's actually on 1, so therefore y equals 58.4 on d squared. Because remember, times in fractions, numerators and denominators times by each other. And that's what would be A for that one. I'm going to skip that one. That one was like a bit of a memory jolt. I'm going to run through this one with you guys. So this question here, the graph shows the relationship between y and 1 and x plus 1. So we want to find the relationship between these two. Now this is x and y, right? So what I've first got to do is find out what this equation is and then see which one is true for this. So what I mean by that is we obviously have our rise on run. So it rises 2, runs 1, so it's going to be 2 on 1, so it's y equals 2 times 1 on x squared, because you just treat it like it is, but it's not x. X is actually this, so you're going to change that. This is still y, so y is there, but the x changes, okay? So I know that that equation is going to be y equals 2 on x squared. So that is my equation. So which one shows this? Well, there's two ways you could do it. You could actually graph it if you wanted to. Alternatively, you can put the value, now that this is x, I can substitute x in and see which one is true. So what I mean by that is that I've got y equals 2 on x squared. This is x, so I'm just going to substitute x in and see if it equals y. So does 2 equal 2 on 1 squared? 1 squared is 1. That means that equals 2. So 2 does equal 2. So it's going to be A. Let's just double check these ones. Y equals 2 on x squared. So we can see that x is 2, y is 1. So 1 equals 2 on 2 squared. 1 equals 2 on 4. 1 does not equal a half, so it can't be this one. Y equals 2 on x squared. Again, because this is x, I'm going to substitute in just for x. Y equals 2 on, whoops, what am I doing? Y is 4. 4, 2 on x, which is 2 squared. We know that's going to be a half. 4 does not equal a half, therefore it can't be that one. Here, again, x is 4. 4 squared is going to be 16. 1 does not equal 1/8. Here, we got 2. 1 on, that's going to be 4 squared. That's going to be a 16th. 2 does not equal a 8th. No, sorry, a 16th. Oh, sorry, it was meant to be 2. What am I doing? That's why I went to an 8th. I was right. Anyway, you get what I mean. So here we have to find out, this one's a bit trickier. So we first have to find out what the equation was. And then from here, what we need to do is substitute in the values of x and y to see if the left-hand side equals the right-hand side. A is the only one that gives us the right answer, because we know the equation was y equals 2 on x squared. So they're saying, hey, the coordinate needs to be 2, 1. So if I put in 2 here, and I put in 1 for x, and I need to square that, it's 2 equals, well, it's 2 on 1, well, 2 divided by 1 is 2. So that is correct. And that's what's the right answer for that one. That's how I'd go about that one. That's pretty much it, guys. This one you will come up on, let's do this as our last question. You can go through the rest of them. Question 14 is a bit tricky. I would recommend you to go through these as well. I've put some in there, but just to finish off, because I do want you to sort of get to work after this, just as a bit of check on understanding, see if you can do this one for me as a bit of a model, and that's about as hard as they will get. And see if you can put in an answer. I'll give you 2 minutes on this one, and that will be our last question. Have a break. No, that's it, yep. Put in your answer when you think you've got it. All right. One answer in. I imagine a few of you, are you guys still struggling? Yes, feel free to say yes if you are. You're not sure. You guys not sure how to tackle this one? Okay. Or you've all fallen asleep, or you're like, bugger this, I'm going out for a walk. All right, let's have a go. All right, I'm going to run through this one with you guys and see if you can help me get there then. The first thing we've got to recognize is that the graph above shows a relationship between y and x cubed. We want to show you something that does that. Well, we've got to figure out what this equation is. So first, let's figure out what this equation is. It's a straight line. So we're going to use the same things as we did before. Chanel, you there? Can you turn off your microphone?
Yeah.
Okay, so you there? Yep. Okay, so Chanel, with this one, what would the equation be? Do you know? Who's that? That's not Chanel.
Sherlock.
Sherlock, no Chanel.
Yeah.
I'm going to get Chanel. Sherlock, bear with me.
No,
Chanel,
fine.
are you there?
Mm-hmm.
Yeah.
Yep. What's your equation for this, do you think?
I haven't done it yet.
Okay, as a straight line,
Yeah.
we've got y equals mx plus c.
Yeah.
Now, we know that the c is going to be 0 because it goes through the origin.
Yeah.
Okay, so do you know how to find the gradient?
Yeah.
Okay, it's rise over run. What is it?
0 over 3 minus 0. So gradient will be 1 over 3.
Yep, so it's going to be y equals 1 over 3 because the rise here is 1 and it rises 3 over, yep, like that. Okay, x. Now, we look at our axes. Are axes the same as these?
No.
No, so what do we need to change it to?
X cubed.
Right, that's our equation. Cool. So it's because it's a straight line, we can treat it as a straight line equation, but then we just change this to that. Does that make sense? So our first step is to find the equation. So we know it is y equals, are you with me, Chanel? That makes sense?
Yeah.
Yep. Okay, the second step is to sub in values so the left-hand side equals the right-hand side. Does that make sense or not?
Yeah.
Okay. Let's look at this one. So we know it's a third x cubed, right? So we've got y equals a third x cubed. What values am I going to substitute in here? We've got 1 and 3, right?
Yes.
So what's this going to read as the equation?
Wait, you meant to substitute the coordinate? So it'll be 3 equals to 1/3.
Great. 2 times by?
Times by 1 to the power of 3, which
It is 1 to the power of 3. Why is it to the power of 3 in this case?
because there's cubes there.
Yep, but it's also because this is x. Okay.
Yeah.
Where if that was x cubed, you'd just you'd still substitute in 1. It's not going to matter, but it wouldn't be 1 cubed. It would just be 1. So does 3 equal? That's going to be 1. 1 times a third is going to be a third. Does that equal?
No.
Therefore, it's not A. Are you with me? Let's look at B. I'm going to run into this. B, we know that it is, what's the equation? Y equals 1 on 3 x cubed. So what's the y coordinate here?
1.
1. Does 1 equal? And we're going to substitute in 3. And is that going to be cubed still?
Yeah.
Yeah, because it's x. And what's a cube? What's 3 cubed? That's 27.
Yeah.
27 times a third, I think, is going to be 9. I'll do the calculations for you. Does that equal each other?
No.
No, because you could just do this on your CAS, right? Everyone could do that on a CAS. So therefore, it can't be B. This gets really annoying. And then this one?
It'll be 1/3 equals to 1/3 x to the power of 3.
Do you reckon that's going to be right?
Yeah, probably.
Okay,
Oh,
that
wait.
is.
Wait, isn't it 1 to the power of 3?
Oh, yeah, you're right. Thanks. I knew that. I didn't. That will be it, I reckon. 1/3 times 1 to the power of 3. Look, I nearly made a mistake. I was just completely leading you astray there, Chanel. That was not my mistake at all. Yeah, that's going to equal a third. Hey, that's it. Well done. Yep.
Yeah.
Cool. So that's one way you can go about doing it, right? Did you like that? Does that kind of make sense?
Yeah.
Yeah, well done. Okay. So it will be, I think it's C. Yeah, I think it is. Let's have a look. Did I do that right? It's a third. 1 is x, 1 cubed is 1, 1 times a third is a third. Yeah, and that's a third. Cool, let's just do the rest of them to make sure we're right. So if that's x, that's going to be, sorry, that's x. That means it's going to be y, 1 equals a third times a third cubed, which is going to be 9, 27. 27 times 3 is going to be like 90. 61, I think it is. I think it's something like that. I don't know, but that's going to equal. And on this one here, we can see it's going to be y equals 1 on a third times 27 cubed. Well, that's definitely not going to be it. Okay, so we can see it's C. So that's one way you guys can go about doing it. Another way you can go about doing it, which not many people know, I don't think they do this on Edrollo, is you can actually go into statistics, right? And we're going to put our coordinates in for each of these. So if I go 1, 1, and then I do 1, 0, 0, sorry, and I do 1, 3 for my next one. Now I know that this is to the power of 3. So what I can do is I can go calc, regression, and do this thing called a power reg. Or I can do a cubic because this is a cubic because it's to the power of 3. Either way, power reg will just identify which one it is. And if you hit OK, oh, I should do it. I've got to do cubic. No, it won't let me do it because I don't have enough coordinates. That one's just not working. But if I do 1 and a third, let's see if that works. No, okay, don't worry about it. It should have worked. No, it's not going to work. We've got to do it that way. Sorry, I thought there was another way we could do it. It doesn't work like that. Sometimes you can use that power reg function. Hopefully that helps you guys. So this is a bit of a two-step one. That's about as hard as it gets. To finish off the lesson, guys, what I really want to show you, what I'd like you to try and do is you're probably going to get 1 or 2 questions of these. You should expect some in your SAC. What I would suggest that you do is you have an example of how to find a K value. I'd have these all on one page. So how to find a K value. So use either of these, how we had a K value. I'll save this annotation and I'll upload it also to our Compass resources as well with our working for you too. And I'll put this video up on our lesson plan as well. Another one I would also do is about how you use a straight line and find the equation of that. Okay, so we've got K value, we've got other ones. And then it starts to blend it together, those two, where we start, and then there's this one where we've got this graph, and then what does it look like as a straight line, which is kind of the other way you can still do it. But then we get to this trickier situation where we need to find the equation, and then we need to substitute the values into the equation so the left-hand side equals the right-hand side, which is just basically the one we went through there. So there's those three types: finding the K value, finding the graph of a straight line, which is pretty much this, and then there's the extra step. Find the equation of this straight line that's not really a straight line, but it's a straight line here, and then try and determine when the left-hand side equals the right-hand side. And that's pretty much most of them. There are some trickier ones where you've got this thing here where it lies on this line here, and because we don't know what power this is, it does get a little bit trickier, but you can, I'll let you guys have a go at that one and we'll review that maybe next lesson. If you can get through this worksheet, you're doing really well on those sub-chapters, but really, I was hoping to finish a bit early, but that's fine. I'm fine with that. I'll just suggest you guys probably to try, if you are behind in work on these sub-chapters, to try just the difficult questions and make sure you do all the VCAR questions. Ideally, I'd like you to do them all, but starting on Monday, I really want us to move ahead. I'm just going to stop the recording there. We don't need to hear this in the recording. So